I have some quick examples of how to use C++, how you write some C++ code. So here we're declaring an integer variable. We want to hold the number of students in this class. So we have int, as we're declaring this to be an integer. Student count, that's just the name that I thought of. There's different names you could come up with. You can call it SC if you want, but student count is a little bit more useful, and we're initializing it to 0. We're going to call some functions here to get the current enrollment. So integer class ID, we have an ID that identifies this class among different classes. So this is the function we will call, will return an integer that will be stored in class ID. Now we want to know how many students are in this class. So we'll call this other function, and we'll tell it what the class ID is that we're interested in. It will look up in the database or in memory or wherever it happens to be kept. That's a piece that we haven't written yet, or it's been written, we don't have it here. But this particular function will return how many students there are. And now this student count has been set to how many students are in the class identified by class ID. Now, we need to get pencils for this class. You have to write things down. You need to take notes. How many will we need? Well, we'll just say we need 12. We'll have a dozen pencils per student. So we'll take the student count. This is the multiply operator. This is an expression. Takes the variable student count, multiplies it by the literal constant 12. And it'll do that arithmetic in the computer and take the result and assign it to this new variable called pencils. I could have said number of pencils, but I'm running out of space on this particular screen. And that is an integer because it is a counting number. You can't have 7.5. Well, actually, you could have 7.5 pencils if you break one in half. But we don't buy them that way. We buy them as integer whole numbers of pencils. Now, we need to add 15% because there are some people who break them in half. And there's people who chew on them. There's people who use them too much. So we will take the number of pencils we calculated already. We'll multiply it by 0.15, which is 15%. This is another expression. And here's another operator. It's a different special type of assignment operator, which we will talk about later in the class, which takes the current value of pencils and adds to it this new expression and assigns that into pencils. So if pencils was like originally was say 100, we multiply that by 15%. That turns out to be 15. We add that to the 100 with the sign equals. And so pencils now is 115. So these are a few examples of doing some arithmetic expressions and some assignments in the variables. And we do all kinds of wonderful things in the code here. Now here's an example with a loop for us. So we want to calculate factorial. Now, if you're not familiar with factorial, don't worry about it. Almost everyone who's taken any kind of high school mathematics knows what it is, but you don't need to know what it is. I'm going to tell you what it is. If you have n and the exclamation point says n factorial, that's n multiplied by the number before it, multiplied by the number before it, multiplied by the number before it, until you get to 1. So in other words, 3 factorial is equal to 1 times 2 times 3, which is equal to 6. 5 factorial is 1 times 2 times 3 times 4 times 5, which is 120. Now, since multiplication is commutative, it doesn't matter whether we go 1 times 2 times 3 times 4 times 5, or 5 times 4 times 3 times 2 times 1, which is what we're doing in this loop. So we have Cin, which is our character input stream. Well, first we declare n, and we're declaring factorial as integers. And then the next line is to grab n as our input that we want to take the factorial of. So start off by saying factorial is equal to n. So if we're 5, factorial is now equal to 5. Now, while n is greater than 1, we will operate this expression. Now 5 is greater than 1, so we'll take 5 and here's another unique C and C++ operator. We will subtract from it. So we'll now have 4, and we'll multiply that by factorial. So now we have 5 times 4, which is 20. Now this is our loop. This open curly brace is the opening of the loop. This closing curly brace is the end of the loop. So we'll go back to the top and we'll test again. Now we've just decremented n, so now it's 4. It's still greater than 1 though. So now we'll take factorial multiplied by decrementing 4, which is 3. And we'll loop again. We'll multiply it by 2. We loop again. We multiply it by 1. So we have 5 times 4 times 3 times 2 times 1, which is 120. But now n is not greater than 1 anymore. So it will skip out of this loop. And cout is our character output stream. And this is the output operator. And we output the result, which should be 120. You can put this into a nice little C code if you want, and you can run it and test it, and it should work just like this. Here's another example. The definition of a factorial is it does not handle negative numbers. What if someone puts in minus 42? Well, we have an if branch for that. So we're going to confirm with some validation code. We'll say, so we'll input the n just like before, but now we have an if statement with an expression. If n is less than 0, we will print out an error. It must be non-negative. You can give it a 0, but you can't give it a minus 1. So if this is not less than 0, if it's 0 or more, then we go into this else branch, which does another if test. If it's greater than 0, we do that same loop that we just talked about a second ago. Now we have one final else to this if. So if it's less than 0, we print out an error message. If it's greater than 0, we do our arithmetic. Otherwise, it's equal to 0. And the definition of 0 factorial is 1. So we just set it to 1 and then print it out. Now let's get a modular example. One of the beauties of C, C++, and many other languages is to be able to break it up into pieces. So let's take all that wonderful code and put it into a function. So we have int, because that's going to be return value. The fact we're going to return an integer. We've named the function getFactorial, and we'll pass in an int called end. Now we no longer have to declare the n inside the function because it's declared as a pass-in parameter. And we have pretty much exactly the same code, except for we're no longer printing the result. We're returning the result as our return value. So then you can have some code somewhere else in your project that either you're writing or a teammate is writing. You can say, well, we've found out the value we're looking for. Let's just call it x. And we want to find the factorial of x. So we say cout. This is just, I got the wrong. The eraser works. So we c in x, and we cout get factorial of x. So whatever the user inputs for x will be passed in to the parameter of this function, which will go in here. It'll do its calculations, return that value, which will go back out here to see. You might not have a cout. You might need that in some other data. You might have declared an f is going to be where you're going to store the factorial, and say f is equal to get factorial. So it's whatever the caller of your function needs to do. So, but the caller of your function does not need to know how to do the factorial. You, as the writer of the factorial, have split this out into a modular piece where you are going to be in charge of doing the factorial, and your teammate just has to call your function to get the answers. Here's another real quick example using trigonometry, which I'm sure everybody just loves to do trigonometry. Let's say we've got a building here. We want to know how high is that building? Well, it's kind of hard to go climbing up the building with a tape measure. So instead, we'll just run a tape measure along the bottom. We'll get a device you can call a sextant, or you can get other devices, and measure the angle. We'll sight to the top of the building, and that gives you a tangent. You can use the tangent trigonometric function to calculate the height of the building based on the angle and the distance of the base of this triangle. So here we have input B, which is our base distance. Input capital A, the quick note that upper and lowercase are different in C and C++. We have a radian variable set to 57.3, which is 57.3 degrees per radian, because the standard library tangent and sine, cosine, all the other ones operate on radians. You might want to work on degrees. If you like radians, then you don't need to do this calculation. But typically we use degrees, so you have to do this calculation here. So we'll take the angle that was input divided by the radians per degree to get our angle in radians, and we're multiplying by B, the base distance, and returning that into A. By the way, I did not declare these variables. I'm assuming that they were declared earlier in the program as being floating point. So we run this calculation and print out the output. That gives us A, the altitude of this triangle, which is how tall your building is. Let's cover a brief history of C++. This was originally designed in 1979 by Bjarne Stroustrup. Don't worry about how to pronounce his name. If you're not born in Denmark, it's difficult. He combines the features from Simula 67 and C to create an object-oriented programming with system-level efficiency. So he created a new language. It went through a bunch of iterations, but he finally, in 1985, published the C++ programming language, which was the first language reference for C++. In 1990, the annotated C++ reference manual was published, and Borland, a company, created, you may have seen that with Turbo C++, you may have seen it with Turbo C, with Delphi, a bunch of other wonderful little programs. It's aptly named Turbo C++ compiler for the IBM PC, and it was aptly named because that compiler was fast, let me tell you. Now, in 1998, the C++ Standards Committee published the first international standard known as C++ 98. And now, in 2011, a new C++ 11 standard was published, which added several advanced features, which we're not going to cover in this class because this is an introductory class. C++ has a number of advantages over any number of different languages. It's a strong type system, which helps avoid errors. There's all kinds of errors, like you say A1 equals something, and you have AL equals something, and that's a typo. Since it has to be declared, if you spell it differently, it will catch that type of error. You could have a character string A1 equals something, a character string, and if you try to add 0 to it, you generally cannot do that in C++. That's a mistake. It will catch that. It's like, no, you can't do that. It combines functional programming with object-oriented programming. Now, object-oriented programming is a very popular, it's a very powerful way to build applications. But there are occasions when it's not the appropriate way to go. The programmer can make that decision in C++, where the other languages, you either don't have it or you do have it. And when you do have it, you can't not have it. So you could use whichever better suits the task at hand. And it's compiled code. Other languages are interpreted, which means the computer has to, when it reads the code, it has to figure out what you meant to do each time it runs that code. There's various ways of optimizing it. Some interpreted languages are very fast, but C++ goes directly into machine code, and you cannot get faster than that. Plus, you have hardware control. Since you're going right into the hardware, if you need to twiddle with the bits, if you need to update a register, if you need to send something down a port, you have direct control of that hardware, which is why it is used in operating systems and device drivers quite a bit. You know, you get more efficiency, you get more control. Other languages just don't give that for you. And there's a lot that you can do with some simple language elements. We're only going to cover the basics in this class, but there's a lot of advanced things in C++ that gives you a lot more things that you can do. But you can do quite a bit with what we're going to cover in this class. Now, there are some disadvantages of C++. It's not as hand-holding and programmer-friendly as other languages. It's not going to say, no, you can't do that. Different other things. You can basically do what you need to do, and which is great for an experienced programmer. It's a little dangerous for an inexperienced programmer, which is why we're going to try and cover some traps and pitfalls to avoid. There's very little or no runtime checking. Some objects in C++ have some runtime checking, but for the most part, if you walk off the end of an array, it will let you walk off the end of the array, which you will at least get the wrong answer, but you might even cause the system to crash. Some languages, you could turn on or off runtime checking because that is a certain amount of performance drain. Give me this variable at runtime because if this variable is valid, then give it to them. Otherwise, put up a type of error message. That's a certain amount of inefficiency involved, which is one of the strengths of C++ that you don't have that. Other languages will have it, and when you need the efficiency, you can turn it off. C++, you don't get it at all. And so there's an old saying, you get enough rope to shoot yourself in the foot. So you do have to be careful programming in C++. Now, the library of tools is not as extensive as other languages. Some languages, anything you can think of, there's a library for it. C++ is not quite that extensive. It is growing all the time. There are companies that are out there that are writing more library functions that will be either incorporated or as at least available for users who want it. There's a company that has something called Boost. If you take a look, if you do a web search for Boost libraries, they have a lot of things out there for C++, many of which were incorporated into the latest standard. So it is an improving situation, but it's not all-encompassing like some other languages. Occasionally you have a problem where a library works differently on one system versus another, which is really not a serious problem. You write everything, you test it. There's usually versions of a library that are available that you can say, well, let me get this from this company, and the PC version from this company will work the same as the Linux version from the same company. And occasionally, because it's not as extensive as there's some tools may not be available on some systems. And occasionally you run into something where libraries are mutually incompatible. It doesn't happen often, but it does happen sometimes. It's something to be aware of. And there are some very advanced features in C++ that are a little hard to figure out how to work them. Basically, what you need to do is take this class. Not this class, because this is the introduction class. Take the next class where we will cover some of the more advanced features and hang on to the code so that you can just cut and paste the code into your new projects to work them the way you need to work them. So, are we ready to get started? This is our introduction, and now we'll get on to the next one. Thank you for watching Educator.com, Introduction to C++. We're ready for lesson 2 now.